Alright, so the next topic is Servlet 3.0 Basics, and this is part of Java EE6. So here we are going to cover easy of development features introduced in Java EE6, and we are going to cover dynamic registration of servlets and filters. We'll talk about pluggability of third-party libraries or frameworks, and then resources in bundled job files. And we are going to cover other topics such as async servlet and security enhancements in Servlet 3.0 Advanced. So we are going to cover just 4 topics. So let's talk about easy of development feature. So some of the easy of development features introduced in Servlet 3.0 includes these 3. Declarative style of programming through annotations. And web.xml file is now optional, so you don't have to have a web.xml file. You still could have a web.xml file. In fact, anything that you have in web.xml file will override the annotations. And better defaults through the use of convention over configuration principle. Okay, so let's take a look at examples of this. So the annotations introduced in Servlet 3.0 includes anything that you specify in web.xml file now could be specified using annotations in your source code. Okay, so that's the reason you don't have to have web.xml file. Okay, so these are the annotations that are defined in Servlet 3.0. Web servlet annotation, this is used for defining a servlet, and web filter annotation is used for defining a filter. Web listener is for defining a listener, and web init param is defining init params, and multi-part config, this is for file uploading properties. And then servlet security is for defining security constraints. So these are the things that you used to specify their configurations in web.xml file. Now all of those can be specified through the annotations. Okay. Again, you can use web.xml file to override the values specified in the annotations. And so this could be a reason why you want to use web.xml file in addition to annotations if you need to override. For example, you don't have a source code and then you want to override. In that case, you might want to use a web.xml file. So let's talk about the first and most important annotation, which is web servlet. So this is for defining a servlet. Okay. So when you use web servlet, one attribute has to be there. That is a URL pattern. Okay, so in web.xml file, when you configure a servlet, you have to specify the URL pattern, right? Okay, so that's something that you have to specify along with the annotations. So we'll see an example in the following slide. Okay, other attributes are optional with reasonable defaults. So if you don't specify these attributes, then default values will be used. For example, the default name of the servlet is the fully qualified class name. Okay. The class must still extend HTTP servlet. Okay, so let's see an example of this. So this is the old Servlet 2.5 example. So in that case, you have to have a servlet. Then in web.xml file, you have to configure the servlet, right? Now in Servlet 3.0, you don't have to have a web.xml file configuration. Instead, this is all you have to do using annotation. So in this case, I'm using web servlet annotation. And if the URL has just single value, then basically single value is a value and this, right? But in annotation, if the value is the name of the attribute, then you don't have to specify it. Okay, so this and this is the same thing. So in this case, this servlet will be used when the URL pattern is /foo. Okay, so this is a case that we have a URL pattern, just one single URL pattern for this servlet. However, if you have a multiple URLs, then you have to use URL pattern. So that is the next example. So in this case, I'm using this servlet for the URL patterns of /foo and bar. Okay, and then I can specify other the attributes. In this case, the name of the servlet is going to be my servlet. Okay, so if you don't specify this name attribute, the name of the servlet is going to be simple sample in this case. And you can also specify other attributes such as async supported equal true. Okay, so we're going to talk about this async support in advanced Servlet 3.0 presentation. Okay, so that is an example of servlet, web servlet. Now let's take a look at the filter. So filter is used. So this is actually for definition of servlet filter. Servlet filter is used to intercept incoming request and outgoing response, and you can do anything you want. You know, you can actually implement like security checking or logging, caching, everything you want to do for each of those requests and responses. You can use a filter. Okay, so again, the filter used to be specified in web.xml file. Now in Servlet 3.0, you can use the annotation of web filter. Okay, so instead of configuring the filter in web.xml file, you are going to use a web filter annotation to configure that filter. So in this case, this filter will be used for URL pattern of, in this case, slash. Okay, and you can also use init params, the attribute. You know, you can use init params attribute in web servlet annotation as well. Okay, so in this case, basically what I'm saying is that, and I'm also using init params attribute for web filter, and then I'm using web init param, and I'm initializing one single parameter, which is name is message and value is my filter. So a single pair of the name and single name value pair will be set as the parameter whenever this filter is used. Okay. All right. So in this case, test filter implements filter, and in this case, so the init is going to be called whenever this filter is actually created. And in that case, basically, we are setting this message variable with my filter. So basically, I'm calling get init parameter method of filter config, and is going to access the message, and the value is going to be returned as my filter. So you know, when this filter is created, this message variable will be set with my filter. Okay, and this is the do filter method. So whenever this filter is being invoked for each of those requests, okay, this do filter method gets invoked. Okay, so in this case, all I'm doing in this case is I'm actually setting filter message key. This is a key, and then the value is going to be the value of this variable. So I'm basically setting filter message key value pair with message, which is set with my filter in the request scope. Okay, so later on in the request scope, I should be able to say get attribute providing filter message, and the value that is going to be returned is going to be my filter. Okay, and then I call next filter in the chain. Okay, all right. So so basically, in this case, we are just using a filter to set this filter message, the attribute in the request scope. This is example 2. So in addition to URL patterns and init param attributes, you can also specify dispatcher type. Okay, so again, this is the dispatcher type. There are in fact 4 dispatcher type, like a request and forward. Again, these are the things that you used to specify in the web.xml file. So you can specify dispatcher type as well, okay, as an attribute of web filter. Web listener, so context listener object gets invoked when the application gets started, right? Okay, so if you want to configure your context listener object, again, you used to have to configure this one in your web.xml file. Now we are using web listener annotation. So I'm basically saying that this particular context listener object will be invoked when the application gets started. So in this case, basically, you know, we are going to just get the servlet context object, and the scope, we are just adding an attribute whose key is listener message, and then I'm basically setting the my listener string value as a value of this key. Okay, so later on you should be able to call context get attribute with this, and then it will return my listener. Okay, right? So that, yeah, so this is actually initialization code, and this is the destroyed code. Okay. We're gonna do this one in the hands-on lab exercise later on. Okay, so I'm just explaining the concept of these annotations. Okay, so you will have some chance to play around with this code. All right, so exercise 1. So we are going to again, for those of you who are attending the JPassion.com code camp for the first time, basically you're going to download this lab zip file. Okay, so I have it already here. So I'm going to unzip it. And I'm going to read the documentation. So I'm gonna go to labs and Servlet basics. Here we go. And index. And the sample applications are provided as Maven project. Okay, and open. So first of all, you just open the lab documentation. Okay, and then you can use either Eclipse or NetBeans to import Maven project. Okay, so so exercise 1, you should do it first. Exercise 0, you should do it first. You want to actually import the Maven project, and then you are going to run exercise 1. So basically, you are going to build annotation wall sample application. Okay. So let me actually show you with Eclipse first, and then I'm going to show you with the NetBeans as well. So let me just close this guy. Okay, so I'm going to import. You want to import the Maven project, so make sure you go to expand Maven and the existing Maven project, and collect next. And then you want to browse into your samples Maven directory of your hands-on lab. So go to, in my case, I have on the labs. So I go to labs, and then Java E6 Servlet 3.0 basics, and on the samples Maven. So you might want to actually import all this application. Okay. Oh, looks like I have those things already imported. Okay. So let's see. Working set. No, this is my previous working set. Alright, so since I want to actually run this application, let me run the NetBeans first, and then I'm going to configure my Eclipse. Looks like my projects have been already open before, and you basically import the project and you just run it. Okay. So when you run the application, this is what we are going to see. Okay. And then basically you are going to study the code. So these are exactly the same code that we have seen in the presentation. So here we are basically writing things out. So that's the reason you're actually seeing message is my servlet. Okay. And and you can actually take a look at the so let me just open project. If you're using NetBeans, you basically use an open project instead of import project. Import project is actually importing like Eclipse project. So even if these are Maven project, you just use the open project. you go to, I'm going to go to labs directory. Oh, not this one, labs. Servlet basics and samples Maven. So you want to import all this project. Let me just close this guy. So you can take a look at the lab documentation, and then there is a for your own exercise. So you know what you want to do is I want to display my servlet too. Okay, so that's something that you want to actually try things out. And 1.3 is a servlet. So this is a case that we have web filter. Okay, so in this case, the init param is set with a message in my filter. Okay. All right. So let me see. This is still actually opening the project. Yeah. So annotation voice here. So let me just run this guy. And you want to select either Glassfish or the JBoss. In this case, Glassfish is pre-configured for NetBeans, and you just run it. And so 1.3 is for web filter, and 1.4 is web listener. Okay, so again, this is the same code. Okay, and you can take a look at the web inf directory, and there is no web.xml file. Okay, 1.5 is you're going to add your own servlet. So basically, you know, new and class, and I'm going to call it my own servlet. And you're going to modify. So basically you're going to actually copy the existing servlet to create the my own servlet here. And basically URL pattern is my own servlet. This is the name, and I'm actually setting my own init params for the servlet. Okay, so my message and passion, and here I'm actually you know, the displaying that message. Okay, and then yeah, so this is what you're going to see when you run the application. Right, and then when you access my own servlet, you should be able to see my message passion. Okay, all right. So I'm going to give you guys about the 15 to 20 minutes since this is the first exercise. Okay. In the meantime, I'm going to actually show. Yeah, so that's NetBeans. So let me actually show you the Eclipse. Yeah. Yeah. So for those of you who have already Eclipse, I have to actually, you know, the configured here. Looks like my project is Alright, so let's move on to the next topic, which is dynamic registration of servlets and filters. So far what we have learned is registration of servlet and filters statically. You can use either web.xml file or annotations. Okay, you can also actually register servlet and filters during runtime. Okay, so that is why it's called a dynamic registration. So let's take a look at that. So what that means is that you can register your servlet during runtime programmatically. So when the servlet context object is being initialized, you can call this method, add servlet method or add filter method from servlet context object. Okay, so you can programmatically register your servlet or filter, and it will return registration object, which you can use for further configuration. So let's take a look at an example. So this is the servlet. This is the servlet context class, which means that this servlet context listener object, this class object gets created and invoked when the application gets started. Okay, so it does have context initialized method which gets invoked. Okay, so in this case you get the servlet context object by calling get servlet context method of the servlet context event. And now what's important is that we can actually call add servlet method to register our servlet called dynamic servlet, and the actual class is this. And then it will return servlet registration object, and then by using servlet registration object you can configure further. So here we are adding a mapping. Okay, so we're adding just a single mapping. We can add another one, we can call add mapping another one, then it will actually add the second URL mapping. Okay, and then we can also set the async support attribute as well. So instead of actually registering your servlet either using web.xml file or using annotation, you can do registration using programmatic API, in this case calling add servlet or add filter. Okay, so you can also look up and configure. So you might want to configure your servlet further during program. So based on your business logic or based on time of the day, you might to configure your servlet differently. Okay, again using programmatically programming API. Okay, this could be used for any servlet that has been registered up to that point. So that servlet could be the configured using web.xml file or annotation, and then you can you can actually find that servlet and then you can do further configuration. Okay, so you can actually call get servlet or get filter registration. Okay, and basically you're going to use a name as an argument for calling this API. Then it will return servlet registration. So this is the code. So basically I like to look for declared servlet. Okay, so this is the name of the servlet that could be configured either using web.xml file or web servlet annotation. And then it will return servlet registration like this. And then you can configure the servlet using an API. Okay, add mapping or set init parameter and things like that. Okay, so basically you are adding attributes using programming API. Alright, so let's do exercise 2. So let's take a look at the exercise 2. So let's go to Servlet Basics, and so this is dynamic registration. So the sample application that you want to build and run is dynamic registration war sample application. So let's actually go to dynamic. This is the one. So you can run as and run on server, assuming that you have already done Maven install. Okay, so when I do run on server, select Glassfish, finish, and it will just display hello world. Okay, alright, so if you take a look at the code, so in this case we are basically so this is the test servlet context listener. Because we have not used any annotation, we probably have a web.xml file configured for this. So if you take a look at the web.xml file for this case, oops, let me just go to the Eclipse. If you go to SRC here, main, and web.inf, and then you see web.xml file, so you can see the listener is configured. Okay, again, we could use the annotation for configuration of this listener, right? Okay. All right. So in this case, we are going to register a single servlet, and then a filter, and then we can also register the request listener as well. Okay. So in this case, basically we look for we are adding a servlet called the dynamic servlet. So we are adding our first servlet called the dynamic servlet, and then you have to provide a full path. Okay, so this is the servlet code, and then we are setting init parameter. So we are setting init parameter called the servlet init name, and the value is the servlet init value like this. And this is URL mapping. So any URL with a star will be handled by this dynamic servlet. This is a filter, so exactly the same kind of concept. we have a filter code, and we have an init parameter, and then we are going to mapping for servlet names. So we are basically using, the when dynamic servlet with a request is actually being invoked, this test filter will be invoked. Okay, so basically this filter will be used along with this servlet. So whenever this test servlet will be requested, this filter will be also invoked. Okay, and then we also register servlet request listener, which is the test servlet request listener. So in this case, this is the request listener. Okay, so when the request and this is actually basically setting listener attribute name with this. Okay, so and this is the servlet code. So in this servlet code, basically what we do is we just make sure that everything is actually working as expected. So basically we are getting the value of the this init parameter, servlet init parameter, that has to be the same as this. Okay, so we are just checking it. So by the time we are calling this servlet, all these things is supposed to be set. So we are just checking that one. If it is different, then we are basically throwing an exception. Same thing for dynamic registration for this guy. Okay, the filter. So this one should be the same as this, and this one has to be the same as this. Okay, and by the time we are seeing this hello world, sorry about that. By the time we are actually seeing this hello world, okay, all these things should actually work fine, right? Okay, otherwise the exception should occur. Okay, so you might want to actually change the value of these things and see whether this is still work. I mean, it should actually throw an exception, right? Okay, all right. 2.2 is we are registering your own servlet dynamically. So basically we are not using the web servlet annotation, since we are registering using we are actually registering the servlet dynamically. So in my own servlet, we are not using web servlet annotation, and instead we want to dynamically register. And basically we are just displaying the init parameter of the message 2. Okay, and then we are going to create and this is the context listener. Okay, so in the context listener we are going to register our new servlet. Okay, in the same way we did. Okay, and then when you run and then test servlet, we just want to make sure we just display the things, okay, from the servlet 2. Okay, and when you run the application, then you should actually see my message 2 is a passion 2. Okay, all right. So I'm going to give you guys about the 12 minutes to try this exercise. Next topic is pluggability. So pluggability feature introduced in Java EE 6 Servlet 3.0 enable the use of third-party frameworks or library without extra configuration in web.xml file. What it means is that before Servlet 3.0, if you are using, for example, Spring Framework or any framework, you have to add framework-specific configuration information into web.xml file. Okay, in Servlet 3.0, you don't have to anymore. It basically let the framework vendor or library vendor to include the configuration information as part of the job file of the framework or library instead of changing web.xml file. So it kind of enables modularization of web.xml file to allow frameworks to be self-contained within their own job file. Okay. This is also actually possible with the programmatic configuration APIs, but we're going to actually mostly focus on job files or framework files to include the configuration information as part of its own job file instead of changing web.xml file. So the motivation of pluggability, this is something I just mentioned. The use of third-party frameworks required possibly complex configuration in web.xml files. So as I mentioned before, if you're using any kind of library or framework, you have to change a lot of things in web.xml file. For example, you have to declare web framework controller servlet and logging and security filters and framework listeners. All these things need to be configured in web.xml file in pre-Servlet 3.0. So it gets pretty complex in web.xml file. Okay, And the framework vendors have to document all these things so that developer configure web.xml file according to the requirement. Okay, so this is a chore for developer standpoint as well. So in Servlet 3.0, now each framework or library vendor can actually include their configuration information as part of their job file in the form of web-fragment.xml file. Okay, so if suppose I'm actually creating a library called XYZ Live, and I can include this web-fragment.xml file under meta inf directory of that job file, and then it will be picked up by the container. So container is going to be responsible for discovering all these fragments of all the job files, and then it will actually create the web.xml file itself. Okay, so the format that you are going to use in web-fragment.xml file is exactly the same, the one you find in web.xml file. So anything that you have to configure in the web.xml file for that library or framework job file could be actually specified in web-fragment.xml file. Now, the container will look for this web-fragment.xml file only in the libraries that are located on the web-inf live directory. Okay, so only the job files in this directory are considered as fragments. So this is a web-fragment.xml file example. Suppose I created a servlet. Well, suppose I'm a third-party vendor, and as a third-party vendor, I want to actually provide a servlet called, in this case, welcome servlet, right? And instead of actually documenting, all the configuration that needs to be done in web.xml file for the developer that use my job file, I can actually create the web-fragment.xml file in and in that file I can actually specify all the configuration I need. Okay, so this is the same configuration, servlet configuration, that I might actually have to have in web.xml file, but inside the web-fragment.xml file. Okay. Now, there could be multiple library files that a particular developer can actually use, right? So, in some cases you want to have order of these fragments. So these fragments, by the way, the fragments I'm talking about, the libraries and the framework job files and things like that. Fragments are identified by name. So each fragment will have a name. Okay, we'll see example of that. The web.xml file can declare absolute ordering of the fragments via absolute ordering. So developer can specify order of these fragments using absolute ordering. Fragments themselves can declare some ordering preferences. It might not be actually taken by the developer or by the container, but fragment can actually specify their ordering preferences using the ordering element, and it could also use a before and after. Okay, and of course, if absolute ordering is specified in the web.xml file, the preferences specified in the fragment.xml file will be ignored. And also, special others elements move fragment to the beginning or end the list of the sorted fragments. So if you use before and others and after and others, so depending on whether you're using before and after, it will be moving that fragment in different location. All right, so let's take a look at the exercise 3. It's a pluggability. So in this case, we are going to have the 3 fragments. Okay, so fragment 1 and fragment 2 and fragment 3. So each of these guys are job file, library job files. Okay, and so here we are creating the multi-module Maven project. So we have absolute ordering web fragment Maven project. And if you take a look at this Maven project, you can see these are child modules. So we are creating fragment 1 and fragment 2 and fragment 3 as a child project. Okay. So here we are going to actually run this project, absolute ordering web fragment project, run as and Maven install. So you can actually build it. So because these fragment 1 to 3 are child projects, all these projects are going to be built. Okay. And then this web project, this is the absolute ordering web fragment project, and you are going to run it. Okay, and what you're going to see is there is a filter message starting. This is actually 2, 1, 3. Each of these are from a different library. Okay. All right. So let's actually run that code first. Okay. So we are going to. So this is the parent project. So parent project just contains a pom.xml file, which includes the child project. So it actually a 4-child project. Okay, fragment 1 and fragment 2 and fragment 3. And then this is the web application that use the libraries of fragment 1 and 2 and 3. Okay, so we are going to build, run as, and maven install. So it's going to build all these 4 modules. Okay, and then we are going to run order web fragment WAV file and run on server. And what we are going to see is 2, 1, and 3. Okay, so each of these number is actually from a different library. Fragment, this is actually coming from fragment 2, this is coming from fragment 1, and this is coming from fragment 3, things like that. So let's take a look at the code. So this is the test servlet. So basically in this case, we are just displaying filter message from the request scope. Okay, so that is actually displaying 2, 1, 3. So this filter message will be set by the library. Okay, now if you take a look at the web.xml file, okay, what we have is we use absolute ordering. So we want fragment called A to be the first fragment to be loaded, okay, and executed, and then the last one should be B, and then we have others. Okay, so there is a fragment whose name happened to be A, and there is the fragment whose name happened to be B. Okay, so A should be the first one, and the B should be this one should be the first one, this one should be the last one, and then anything else is actually in between. So this is the one, A fragment is going to display 2, and this is one that display 3, and this others, we have a 3 fragments, so this one should actually display 1. Okay, so now if you take a look at the jar files, fragment 1 jar, fragment 2 jar, and fragment 3 jar, if you take a look at each of so these are the jar files that are under this fragment WAV file. Okay, so if you take a look at this, you can see the src, main, and web app. Oh, we actually supposed to go to target. Yeah, so here, so you can see these 3 jar files actually on the live directory, right? Okay, so if basically we are creating this is a fragment 1, this is a library that actually gets created. Okay, so if you take a look at the target, this is actually fragment 1 jar file that gets actually copied over here. Okay, so that's the POM file that we do. Okay, all right. So let's actually take a look at the documentation. So now if you take a look at the fragment 1, fragment 1 does not have the fragment XML file, while fragment 2 has web.fragment.xml file, while fragment 3 also has a web fragment.xml file. Okay, so if you take a look at the fragment XML file of the fragment 2 library, okay, so let's take a look at that. You can see that is the one that contains name A. Okay, so this is the one that will be configured as the first. Okay, and here we configure the filter, W2 test filter, right? And the fragment, yeah, so this is basically, the same code that we have seen here. Okay, so this is the fragment, the name A. So this is the second fragment, but named as A, and this is actually test filter code. So if you take a look at the test filter code, All right, that's where it's actually setting 2 to the filter message. Okay, so that's fragment, the second fragment was actually adding 2. Okay, all right, so this is the same code. Now, if you take a look at the fragment file of the third library, it works pretty much the same. So here, that's the name B, right? Okay, and again here, this is the case that we are actually here you don't actually see any filter configuration in this fragment, because here we are using annotation, right? Okay, and this is the one that actually add 3, but this one's supposed to be configured the last, right? So third fragment will be displaying 3, and then we have the first one. Yeah, this is the first fragment, which doesn't even have any web fragment file. Okay, again, it's actually using filter, right? And it doesn't have a name, so it doesn't have to have its own fragment XML file. And this belongs to the others. Okay, so that's the reason we have display of 2 as the first one from the second library, and 3 as the last library, and then this one is actually in the middle. Okay, so for your own exercise, I want to actually display like a passion, the after one, so 2, 1, passion, and 3, something like that. Okay, so what you want to do is you want to actually create another library, and that actually generate the passion and add the filter message. Okay, all right, so I'm going to give you guys 10 minutes to try this exercise 3. Okay, yeah, so there was a question about the configuration of this project, so let me just explain this project structure a bit. So as I said before, the parent project, this is in fact the Maven thing. So the parent project has these child modules, fragment 1, fragment 2, and fragment 3, and the WAR file. So this is the project that actually use jar files that are created in the 3 different projects. Okay, so it's possible that these modules are in fact actually from third-party vendors and things like that. So if you take a look at these WAR files, pom.xml file, and you can see on the target these jar files are actually included, and these jar files are in fact created from this fragment. So let me just create the fragment 1 just to see what gets created. So I'm going to actually run as and Maven install, and what you're going to see is so it actually installed this jar files. So installing this jar files, this jar file, fragment 1 jar file is now installed in my the local repository as fragment 1.snapshot.jar file. Okay, this is my local repository. So any project that needs this guy as a dependency will actually get it from my local repository. Okay, so that's, and now if you take a look at the WAR files pom.xml file, this is the WAR files pom.xml file, right? You can see it has a dependency on these fragments, fragment 1 and fragment 2 and fragment 3. And now it also actually uses Maven dependency plugin. What it means is that all the library jar files will be included as part of the WebINF live. Okay, so that's the reason you see these jar files on the live. So when you run the application, when you actually build from the this guy, it builds all these things. It will create it will build fragment 1 to 3 first, because those are dependencies and of the this WAR file, and then this WAR file will be this WAR file project will be created, and these jar files will be as a dependency will be included in live. So when you actually take a look at the WAR file, in fact, directory structure WAR file, this will reflect this. Okay, so hopefully that gives you a sense of how this particular project is being built. Okay, so let's move on to the next topic, the last topic of resources in a bundle jar file. Okay. So static and JSP resources, JSP pages, no longer confined to web applications document root. So before Servlet 3.0, the static files, JSP pages, need to be located under the root. However, in Servlet 3.0, those resources could be actually part of the jar file. Again, you could actually have a bundled jar file from a third-party vendor, right? And if that third-party vendor wants to include some static resources, static pages or JSP pages, they could have those pages under the jar files meta-inf resources directory. Okay. Again, container will look for these resources under these jar files. Okay. And the APIs like a get resource and get resource stream method, these methods should also honor these resources. Okay. However, resources in the document root take precedence over those bundled in the jar file. So, if a particular JSP page is looked for, if it is already available in the root, that will be taken. Okay. If it is not available, then it will search for the jar files. So this is an example. Suppose we have my web app WAR file, and it does have index.jsp page, and then it contains share.jar file, which is on the web-inf live. On the jar file, let's say we have directory structure called the meta-inf resources shared JSP page. Now, if there is a request coming in, localhost 80 in my web app and share.jsp, because JSP is not in the root, it will search for all the libraries on the live directory. Okay, so because this shared jar file has this one, it will pick that up. Okay, so if you take a look at the bundled jar file directory structure, that is in fact the hello world.jsp page. Okay, and that hello world.jsp page will be displayed. Okay. Okay, so that is exercise 4. So let's take a look at the lab documentation. Okay, so lab documentation is resources in the bundled jar file. Okay, so when you run the application, you're going to actually see hello world being displayed, and this is actually from hello world.jsp page under the jar file. Okay, so let's actually take a look at that. Let's just run it. So let's run. So if you actually see 4.4, that's typically, let me actually refresh just in case it actually gets displayed first. If not, then we have to just rebuild it again. So Maven install. Okay, it's built, and now run as, run on server, and finish. So I'm having some issues with this one. Let's actually go to the server, and let's just Windows servers. No servers here. And I just I'm gonna run it again. So it's actually 4.4 error. So let me actually see what's going on. File. There's nothing. Looks like it's fine. Dynamic resource jar file. So I'm going to try with the netbeans so that I can actually dissect this job file a bit. Let's stop the server. Okay, the same problem. So it looks like there is some issues. Let's see. Target and all file and meta inf. Oh, this live. Okay, so this is a job file. I want to actually dissect it. And okay, so there is actually hello world.jsp page. So I am going to go. So it should be hello.jsp page. So let's go to. Source. Oh, it has to be jsp.js. So let's see. JSP. Okay, so that's the one. So I should actually say JSP hello world.jsp. Okay. So why I'm not actually seeing that one when I run the application. So web.inf. Oh, maybe the documentation. I didn't read the documentation correctly. So I should actually, yeah. So you have to actually go this link. Okay. So JSP 5. Oops. Oh, the link is actually not correct. The link is supposed to be resource bundle job file. So this is the one. It looks like a link is incorrect. Let me just run this guy. Okay, that works. Okay, so so the link is somehow, the documentation link is somehow incorrect. All right, so let me just make sure the documentation link is corrected.